Hey, Dr. J here with a couple loose ends, or in particular one loose end from 7.2. I'm going to give you a recipe. I have to use a new pen. A recipe for rewriting anything of the form A sine x plus B cosine x into K sine x plus phi. And this is if you want a quick way to just take the given problem, plug it into this recipe, and boom, you get your K and your phi is what you're solving for. So K is the easiest one. K is the square root of A squared plus B squared. Yeah. And then you have three choices for phi. Yeah, you can use sine. Sine phi would be B over K. So you already have your K and you already have your B. So your sine would be B over K. Or you can use cosine, which would be A over K. Or you can use tangent, which would be B over A. So all three of these should work to find the value of phi. You do need to use the inverse function. So once you know the sine, you're going to do the inverse function. You want to pay attention to the plus or minus signs, the other kinds of signs. That will determine whether or not the angle is in quadrant 1 or whether it's in quadrant 2 or something like that. Okay, so using this recipe, you can easily get your K and phi values. So suppose we had something like 3 sine x plus 4 cosine x. So this is our A and our B. So we might as well jump right to here and figure out what K is first. I'm going to move it over here. Give myself a little space. So I've got 3 squared plus 4 squared. I picked some nice numbers for this one. So your K would be 5. So now you've got 3 choices for your phi. If you use sine, sine would be 4/5. If you use cosine, cosine would be 3/5. Or if you use tangent, tangent would be 4/3. Now, all of these are positive. So we are in quadrant 1. In other words, phi is less than 90 degrees. It's somewhere between 0 and 90 degrees. These should all give you the same value. You don't need to actually do it 3 times, but I'm going to, just to give you the idea that you have choices. So you have a sine inverse of 4/5. So let's see, 4/5 sine inverse. So that's 0.9273 radians, which is about, if you multiply this by 180, and then divide it by pi, you get about 53, I want to say 53 degrees because I'm approximating. That's definitely less than 90 degrees. Remember, pi over 2 is 90 degrees. So. Now, I don't necessarily have to do it 3 times, but I want to make sure that you see that you have options. So suppose you use cosine. Sometimes one of these will give you a positive, and one of them will give you a negative, and you might have to decide which one makes sense. These are all positive, so we're in good shape. So we have 3/5. We're using cosine inverse, and you still get the same value, 0.9273, which is still 53 degrees. Okay. And you can also use tangent. This is actually my favorite. So you get tan inverse of 4/3. It should still come out. Let's see, 4/3 tan inverse. Yep, exactly the same. 0.9273 radians, which is 53 degrees. Okay. So keep in mind that one of the reasons why you have these 3 choices, let me go ahead and write the answer now. So the answer will be my k is 5 and my phi is 53 degrees. So this is 5 sine x plus 53 degrees. Or in radians, just read whatever I'm asking for, x plus 0.9273. There's 2 different answers. One of them is degrees, and the other one is radians. One of the disadvantages of using your calculator is your radian measure does not come out to be something that looks familiar to you. You can't tell, is that pi over 6? Is it pi over 9? Is it pi over 13? It's very difficult to see what that is. My guess is it's about, I don't know. One thing is pi over 3 is about 1. So this is pretty close to pi over 3. Pi over 3 is a little bit more than 1 if you divide it on your calculator. Pi divided by 3 is 1.04. So in your mind, this is a little bit less than 60 degrees, right? So pretty much what we got down here, 53 degrees. Yeah. So degrees are a little bit more, understandable for the human mind. You've been probably measuring things with degrees your entire life. So radians might be sort of new for you. And then I'll give you a warning when we get more into the inverse functions in the next section. In the next couple sections, you got to be careful. The domain for the sine inverse, the sine inverse function will give you a number between negative pi over 2 and pi over 2. So when you put this into your calculator, you're always going to get a value that's between negative 90 degrees and positive 90 degrees. That's what's going to happen when you solve this thing. Okay. When you do the cosine inverse, your domain ends up being 0 to pi. So from 0 to 90 degrees, that's where your phi ends up between not 0 and 90, 0 and 180. Pi is 180 degrees. So that's the reason why I give you 3 choices, or why we have 3 choices. It depends on what quadrant you're in. If you use the sine, it'll put you in quadrant 1 and 4. If you use the cosine, it puts you in quadrants 1 and 2. Yeah. And then the tangent is the same as the sine. the domain for that would be negative pi over 2 to pi over 2. So again, it would give you an answer somewhere between negative 90 degrees and positive 90 degrees. So that's also quadrant 1 and 4. All right, so you'll never get an answer in quadrant 3. None of these have a phi that would land in quadrant 3. We'll try another one. So let's look at another example of rewriting this expression in terms of sine. If you don't see the coefficients a and b, that means they're 1. All right, so you have invisible ones here, and in particular, this one is a negative 1. So we have a is 1 and b is negative 1. So let's find k first. That'll be 1 squared plus negative 1 squared, so that'll be the square root of 2. Okay, now we have 3 choices to find phi. Phi is sine inverse of negative 1 over square root 2, or cosine inverse of 1 over square root 2, or tan inverse of negative 1 over 1. All right, so this one is b over k, this one's a over k, and this one's b over a. Now, you might not want choices. You might, why do I need 3 choices? Well, because you might get 3 different answers, and you have to think about what's going on here. So let's go ahead and try this. Watch. So suppose I do sine inverse. Okay. So I get, you might recognize this. This is a special angle, but suppose you don't. Okay, so suppose you get 1 over square root of 2, and it's negative. So that's sine inverse of negative 0.7071. Watch what happens when you hit sine inverse. You're going to get negative 0.78539, etc. radians. Convert that into degrees, or you can leave it as radians if the question is asking for radians. If you like to think about what this actually means, I prefer to turn it into degrees. Just multiply it by 180, divide it by pi, and you're going to get negative 45 degrees. You probably should have recognized that. This is one of the special angles. So if you get an exact number like 30, 60, 90, 45, one of the special ones, then you know you probably could have skipped the calculator step and just jumped right to here. Okay, so negative 45 degrees. But watch what happens when you do cosine. Yeah, watch what happens when you do cosine. The cosine is positive. Yeah. So when you do cosine, you get, well, let's just do it. So we got square root of 2, or 1 over the square root of 2. So again, you have 0.707, but it's positive this time. And then when you do cosine inverse, you're going to get positive 7853, which is positive 45 degrees. And these don't agree with each other. Yeah, it can't be both. And then tangent will also give you, tangent is the same as sine. It'll give you the same value. So for tangent, you'll also get tan inverse of negative 1. Probably don't need a calculator for that, but I'll do it anyway. Negative 1 and then tan inverse. And I still get the same as the sine. The sine and the tangent typically give you the same value. So you get negative 0.7, blah, blah, blah. So this is negative 45 degrees. So how are you going to know which one is correct? All right. Well, you have to look at the quadrants. Yeah, in quadrant 1, sine is positive, cosine is positive, and tangent is positive. So you know it can't be in quadrant 1 because these are not all positive. Yeah, so it cannot be this one. Yeah, because that would be 45 degrees in quadrant 1. Yeah. In quadrant 2, sine is positive, cosine is negative, and tangent is negative. Yeah. Is that true? No. See, look, the sine is negative, the cosine is positive, and the tangent's negative. Yeah, so the sines and the cosines are in the wrong position. So I know it can't be in quadrant 2. You'll never get an answer in quadrant 3. The inverse function is sort of restricted. All three of these inverse functions restrict you to either quadrants 4, 1, or 2. You'll never get an answer in quadrant 3. It's one of the sort of missing gaps in the inverse function when you're using your calculator. All right, so now you're down here in quadrant 4. Cosine is positive, sine is negative, and tangent is also negative. This is the winner. Yeah, because look, sine is negative. Yeah, check. Cosine is positive. Check. Tangent is negative. Check. So I know I must be in quadrant 4. So the correct answer is negative 45 degrees. Yeah. Negative 45 degrees is the same as 315 degrees. So either one of these would be correct. So you got two correct answers for this. One of them would be square root of 2 sine of x plus negative 45 degrees. Or in other words, x minus 45 degrees. Or in radians, pi over 4. You could also use 315 degrees. Which would be, you remember your radians, that's 7 pi over 4. This is an unusual answer. Most problems require phi to be less than 90 degrees. So, I mean, this is technically correct, but there might be a restriction on the phi. So make sure you read carefully as to which of these answers the question is asking for. Okay. Alrighty, just wanted to get that out there. This kind of missed the boat yesterday on the lecture, so I'm going to go ahead and upload this today before I post the next section. So Dr. Jordan signing out.